Assalamualaikum and hi everyone. We are Group 7 for the course SEAB 2022. For this assignment, we wanted to see how engineering works in the real world. We did not want to just read about it. We wanted to understand the actual responsibility of an engineer in the site. To get real answer, we interviewed our Sheikh. Speaking to him gave us a clear picture of the technical document and the site condition. Our goal was simple. We wanted to identify the challenge they face at work and propose solutions that are sustainable and good for the community. The project we choose is located at Jalan Tampoi, Johor Bahru. It is a government project to upgrade facilities for the elderly and destitute. The client is the Ministry of Women, Family and Community Development, and the main contractor is Sakiza Indah Sendia Berhad. It is a massive project worth 57.39 million ringgit. It started in 2022 and it's scheduled to finish by July 2026. So, what are they actually building? First, they are building better residential zone for the elderly. Second, they are constructing a 10-story apartment block for staff housing. And third, they are building community facilities like a dining hall, a prayer room and medical room. This project shows us that civil engineering is not just about concrete and steel. It's about building a better quality of life for people. Thank you.
There are 4 challenges that I get from this project. First, soil condition. Second, material delay or exceed budget. Third, get workers to follow safety rules. And lastly, handling unreasonable design change. For soil condition, we need to do a soil investigation to determine the safe-bearing capacity of the soil is good or not. If soil is weak, we need to redesign the foundation by increasing the size of footing. It can help to distribute the load evenly. Other than that, when the material are suddenly delayed or exceed the planned budget, we can claim the VOP, which allows the project budget to adjust when material prices change. In some cases, the government will help to cover the cost of material, so we can claim back any extra cost if prices go up. We can also make agreement with suppliers to lock price at certain amount of material. Next challenges is to get workers to follow the safety rule at the site. For example, works related with height need to wear safety harness. However, workers underestimate the risk and neglect it. So the site supervisor should routinely do inspection at the site. Lastly, the challenges in handling the unreasonable design change requests. Sometimes, client want modification to reduce cost. However, the changes will not comply with safety and engineering standards. So, engineer need to advise client by explaining the risk and importance of the original design.
For this project, IBS method were used to make construction faster and easier. Because columns were used to reduce on-site concrete works and save construction time. Lightweight trusses were used instead of timber trusses because they are easier to install. Plastic formwork was used instead of timber formwork because this help reduce material waste and labor work. Overall, this method reduce the need for foreign workers and improve construction efficiency. Besides ABS, digital technology was also used on site. Drone photos were taken to monitor construction progress and observe the site condition. This makes site supervision easier and helps improve progress reporting. It also reduces the need for frequent manual inspection and improve safety for the workers. Even though the technology is simple, it shows that the project is moving toward modern construction method.
Hello everyone, my name is Muhammad Shahmi bin Asmawi. Moving on to Part D, I will be discussing the intellectual property or IP component. In our case study of the Rumah Seri Kenangan project, we found that IP is critical not just for protecting business interests but for ensuring professional liability and public safety. We identified 4 specific types of IP relevant to this project. The first one is copyright. This is the primary protection, which is automatically covers the engineer's technical drawings and blueprints as artistic works. which is under the Copyright Act 1987, yes. The second is patents. This would apply if the project used a brand new technical invention, such as unique method for joining precast columns that had never been seen before. The third one is industrial design. These protect aesthetic features like a unique visual pattern on the facade or formwork. Finally, trade secrets. This protects the firm's confidential data, such as their proprietary calculation spreadsheets or internal material cost databases. A key finding from our interview is about ownership. There is a misconception that the client owns the design because they paid for it. In reality, the consultant retains the copyright ownership. The client typically receives a license to use the drawings. This means they have the right to build the design only for the specific site. So they cannot replicate this exact same building in another city without the consultant permissions. We must protect this IP for 3 reasons. The first one is to prevent loss of competitive advantage, so the competitors don't copy unique methods. And the second one is to avoid legal infringement lawsuits. And the last and most importantly is for public safety. If technical plans are leaked and used elsewhere without the original engineer's supervision, the building could fail and the original engineer could still be held liable for the design. That concludes the IP component. Thank you.
Next, I will discuss how this project reflects the future of civil engineering. In terms of sustainability, the project supports Sustainable Development Goal SDG 11 by using an industrialized building system IBS, which reduces construction waste and improves material efficiency. The use of reusable plastic formwork also supports sustainable construction practices. For climate change and resilience, the project follows the latest manual saliran mesra alam MESMA to manage extreme rainfall and reduce flood risk. It also considers earthquake resistance based on professional guidance, showing a proactive approach to future risks. The project also demonstrates digital transformation through the use of drones for site monitoring, improving accuracy, safety, and efficiency. Finally, professional ethics remain a key responsibility of civil engineers. The engineer emphasized that safety and ethical standards must always come first, even when facing pressure from clients. Overall, this project shows how civil engineers must balance technical skills, innovation, and ethical responsibility in a global society.